Things like number of students in a class or number of pages in a book will always be natural numbers. We cannot have 4.25 students in a class or 200.5 pages in a book. This kind of data is called discrete data. Each person or each page is a countable set of values. Sometimes we may need the heights or the weights of students. Well, the heights and weights need not be natural numbers. The weight can be something like 58.65 kilograms and the height can be something like 165.26 centimeters. This kind of data is called continuous data. They are not a countable set of values. For instance, if the heights of students in a class range from 150 to 170 centimeters, we cannot count the different heights in between. The heights can be anything like 150 or 150.11 or 155.2518. What does all this tell us? It tells us that the way we use grouping for each type of data will be different. Let's zoom out and first understand how discrete data can be represented using grouping. For discrete data, our class intervals can be something like 1 to 5, 6 to 10, 11 to 15, and so on. This is called discontinuous form of grouping. You can see that the upper limit of a class is not the same as the lower limit of the next class. And what do we use for continuous data? For continuous data, we have class intervals like 1 to 5, 5 to 9, 9 to 13, and so on. This is called the continuous form of grouping. This will include even decimal numbers like 5.5 or 7.85. All this was simple, wasn't it? Maybe, but there should be one question that should pop up in your heads. Look at the continuous form of grouping. What if we have a number 5 in our data? Which group would you include it in? 5 is present in the first group and the second group as well. Try to recollect the rules for making groups. One of the rules said that the group should be non-overlapping. Are these groups non-overlapping? The next point should clear our doubts. In the continuous form of grouping, 1 to 5 means 1 less than or equal to x less than 5. It means that the number 1 is included in the first group, while 5 is not included in it. In the same way, the second group would be read as 5 less than equal to x less than 9. It means 5 is included in the second group, but not 9. That answers our question. 5 is included in the second group and not the first. Similarly, 9 will be included in the third group and not the second. So do not assume that the groups are overlapping.